So I was just like, oh, that would be really good fun. And they didn't decorate the hallways.
So next thing, we talked about our radicals yesterday and a little bit about domains. We know if it's an even radical, what has to be true? The thing under the radicand is greater than or equal to 0. If it's an odd radical, then can be anything. Okay, and we know how to go back and forth if it's written as a fraction versus written as a radical and vice versa. So today we're going to start solving equations with radicals. And we will have to watch. Sometimes we might get solutions that don't work. And it doesn't work in the cases when you have an even radical. You know, whatever's under the radical has to be positive. Now, am I going to have to worry about that here? No, because we have a cube root, and so that's odd. It could be anything. If we want to solve these equations, our strategy is to first get the radical by itself. We have to isolate it on one side of the equal sign. So we'll add over our 2 to begin. Okay, and we've kind of seen this with square roots before. If you want to get rid of a square root, what do you do to each side? You square each side, right? Because that cancels the square root. So what would be the opposite of a cube root? Cube. So we cube each side of the equal sign. So cube root and cube cancel out. And 2 to the 3rd power, 8. So then we just solve our equation. Add over our 4, divide, and x is 6. It's good practice to check these. Like we said, we can get answers that don't work. We already know it won't happen here, but you can easily put it in. If you put in a 6, 12 minus 4 is 8, cube root of 8 is 2, minus 2 is 0. So we can always double check our answers. You guys try that one. Cube each side. So 2t minus 1 equals 1. So 2t equals 2 and t is 0. If you check it, does it work? You get the cube root of 1, which is 1. Alright, let's go to this one. The radical is by itself. However, I can't just go through and square each term. We have to think of it as you're keeping it balanced. So whatever you do on one side of the equal sign, you do on the other. On the left, the square root and the square root cancel out. What happens on the right? The whole thing gets squared. So how do we do that? FOIL. It means we have x minus 7 twice. So x squared minus 14x plus 40. So now, what do we do? Take everything over to the right, so my x squared will be positive. So if I subtract my x, it's negative 15x. Add my 1 plus 50. So that factors into x minus 5, x minus 10. So we get x to be positive 5 or positive 10. What do we need to do at the end? Check. Okay, so if I put in a 5. 5 minus 1 is 4. Square root of 4 is 2. But 5 minus 7 is negative 2. So does that one work? No. If I put in a 10. So I get square root of 9, which is 3, equals 10 minus 7, which is 3. So that one does work. So 10 is my only answer. Just as heads up, it's not like you're guaranteed to only get one answer on these. You can have 2 answers, or we might check them and neither one of them works. So you can't just say, oh, I checked one, it didn't work, so the other one has to. You have to check all of your answers. that one okay? Look at this beautiful problem. Where would you begin? Mm-hmm. So how would I get rid of this? Square. So we square each side. Okay, so on the left, that cancels the first square root. On the right cancels that. So now, so you have an option. You can divide the 2 over so the radical's by itself, and that's kind of what I told you to do, isolate it. The downside of that, you will get some fractions then. So if you are opposed to that idea, as long as this is one term, we could square it right now. So as long as there's no plus or minus, we can square from this point. When you do that, if it's one term, the square just goes to both pieces. So 2 squared would give us 4. Square root of 7x plus 2 squared would give us 7x plus 2. Cancels the square root. Then on the right, if I'm going to square that whole thing, we have to FOIL. So we get 9x squared plus 6x and plus 6x would be plus 12x plus 4. So that's 4. We always set quadratics equal to 0. So subtract the 28x, subtract the 8. Now what? What multiplies to negative 36 and adds to negative 16? Positive 2 negative 6. Mm-hmm. So we get 9x plus 2 times x minus 2 equals 0. So that gives me x to be a negative 2 ninths and positive 2. Now what? To check, we have to go back to the original problem. Looks like this one is not going to be beautiful. So to check negative 2 ninths, you are welcome to do that on the calculator. So we have the square root of 2 square root 7 times negative 2 ninths plus 2. And it's going to give us a lovely decimal. And if we plug the negative 2 ninths in the other side, we're going to see if we get the same decimal. Does it work? Everyone should check and make sure you know how. Also, I'm missing calculators. They're going away Monday if you can't find my calculator. So please.
Yes.
Okay.
Oh,
Oh, really? If you locate one today, it doesn't appear to be in someone's possession, you might just bring it back to me. Thank you. They're the same, so that one works. Everybody get it? And then the other one we have to check is 2. So if x is 2, plug that in. And that also works. So this time we got 2 solutions. So that one was a little bit longer because we had to square twice. Are there any questions about it?
Let's try this one.
Where do we begin? We need to square to get rid of square roots. However, if I start squaring from here, what will I have to do on the left side? And to square that, we have to FOIL with all those radicals, which we can do, and we're not going to be able to completely eliminate that. However, it's probably easier to square with only one radical on the side. So this is going to be a problem where we're going to have to square a couple different times, but it's easier to get rid of one at a time. So I'm going to add this over, and then we can square. So on the left, we cancel and we get 2x plus 3. On the right, to square, it means we have 2 of them. So 2 times 2 is 4. When you multiply those, the 2 just stays outside. So 2 radical x minus 2 and 2 radical x plus 2 would be 4 radical x plus 2. So to add them together, you just add their coefficients. What happens when you take radical x plus 2 times radical x plus 2? Alright, so that step was a little bit uglier than the other ones. Does anyone have any questions on how we did that? Or where any of my terms came from? So now, we still have a radical. So we need to isolate this radical so we can get rid of it. So if I subtract over my x, that would just give me an x over here. 4 plus 2 is 6. If I subtract that over, that's a negative 3. So now we can square again. On the left, you have to FOIL. So we get x squared minus 6x plus 9. On the right, you have to square the 4, which would become a 16. Square the radical x plus 2, which is an x plus 2. And then we distribute that 16. Set it equal to 0. What multiplies to negative 23 and adds to negative 22? So we get x to be positive 23 and negative 1. And then what do we have to do? Check. Put it back into the original. So if we plug in a 23, square root of 49 minus the square root of 25. 7 minus 5 does equal 2, so that one's good. We plug in a negative 1. We get the square root of 1 minus the square root of 1. And 1 minus 1 does not equal 2, so that one does not work. So 23 is our final answer. All right, that one was significantly longer. Do you have any questions about it? Why don't you guys try one of those? So I'll give you a few minutes to see how far you can get before. So to isolate this radical, we add over the second one. And then to square, we have to FOIL on the right. So we get 3x plus 1 equals, so if we write that twice, 2 times 2 is 4, plus 2 radical x minus 1, plus 2 radical x minus 1, plus radical x minus 1 times radical x minus 1 just gives you x minus 1. So if we combine like terms, now what? We need to get all that extra stuff over so we can square and get rid of this radical. So if we subtract our x, subtract our 3. Did anyone catch that right now everything's divisible by 2? Okay. If you did, you could have divided and just given yourself some smaller numbers, but if you don't catch it, it's not a big deal. So if we square now, over here, we have to FOIL. So you get 4x squared minus 4x and minus 4x will be minus 8x plus 4. Over here, you have to square the 4 and square the square root. So we get 16 times x minus 1, or 16x minus 16. Quadratic set it equal to 0. Now what do you see? You can either factor out the 4, you could also divide it on both sides. Either way is fine. If you had divided by 2 earlier, you wouldn't be able to do the 4 now. So we'll catch it either way. So this factors into x minus 5, x minus 1. So if we set those to 0, we get x to be positive 5 and positive 1. Am I done? No, we have to check them. Okay. So plug in a 5. We get the square root of 16 minus the square root of 4. And 4 minus 2 does equal 2. We plug in a 1. Get the square root of 4 minus the square root of 0. And 2 minus 0 does equal 2. So this time they both work. How are we doing with these? so then we have a second type of problem. I can either do those today or I can save them for Monday if you want to practice just this. What do you guys think? Save the second type for Monday? Okay, so there's a Math Excel assignment open. It's actually the assignment for the entire section, so you don't know how to do it all yet, but you can start working